So welcome. It's
Oh,
Monday,
oh,
February 9th, and we are doing our weekly online meeting for the DiscoBots. We're going to talk a little bit about meeting schedule because Valentine's weekend is closed for Lamar on Saturday. So our plan is to meet on Friday evening or Friday after school at Lamar, collect the pieces we need, and then we will go to my house in my garage to work on the robot. Um, so we will do a kind of a garage meeting on Saturday, and we'll post the details and the address and all that kind of stuff. And then we'll go back to our normal schedule the next week. So
are classes scheduled for Friday or is it
Yeah,
just each week?
Friday is a staff PD, so the building will be open, but there won't be any classes, and
Okay.
students are off. And it's the same deal on Monday as well. Or Monday is a President's Day, so the all of HIZ is just closed.
Okay.
yeah, we might have to discuss tomorrow at Lamar whether we need to take some stuff early, just in case. So anyway, we got some scheduling issues because of the weekend break, but we'll figure it out. In terms of progress, we posted some videos of the Spindexer, posted videos of the shooter, and we really didn't get to work on the intake much. But they did some good path planning with the 2025 robot, and so it made some good progress in a bunch of different ways. But we still have a lot of CAD details to work out. So I don't know how much more we want to get into the overview, but I think we're getting a good turnout. We encourage everyone to show up to these meetings, especially the Saturday meetings, because that's when we get the most work done. And we need to remind ourselves that we are pushing to March 1st is our competition ready day, is the way to think about it. So that is going to be at Paradox. This is in Pearland. We will have about 6 hours on a Sunday to run practice matches and to try to, have the intake, the Spindexer, the shooter, and the bumpers working to the point where we can move on the field and shoot balls is our goal. We might not shoot very well, but if we could do a little bit of picking up and shooting balls by March 1st, that's going to be a really big milestone for us. So, any other scheduling things that we should talk about? Okay, Cedric, I'll let you run the show.
All right, so we made pretty decent progress. The CAD wise, there's still just a billion details that need to get put in, and we're slowly working towards that. We did a lot of really good testing on Saturday, especially with the Spindexer. We actually found that with the way that we have it set up here with a short wall, the brushes are actually quite problematic. And so we actually tried kind of a stacking like a cake using 4-inch wheels and then a 3-inch wheel and a green compliance star on top. And we found that worked incredibly well. It was really violent, which is, I think, exactly what we want. So I will hopefully make that change in CAD here soon. Add in the wheels because I think we're pretty happy with how that went. And so I think the Spindexer isn't final, but it's probably the most developed thing that we have on our robot right now. So yeah, we're pretty happy with that. We also tested the shooter. The shooter was a bit tougher to generally test just because there's just a lot more that goes into it. It's not a subsystem that can really easily be tested. But we put it onto a sim motor, and we kind of found that like we didn't shoot very well. I think we shot maybe like 6 feet or something like that, kind of just across the room a little bit. So the shooter's going to get a bit of a rework. I think the big thing that I really need to really is just lacking a bunch of detail right now is the hopper. I realize it's not actually as straightforward as I initially thought. Just because like, especially on the side where we have the intake here and over the climb, there's just not that much space to. It's hard to find the balance between creating a good support for each of the hopper panels while still maximizing our fuel storage. So I'm still really just slowly working towards a more detailed funnel. We cut out like temporary panels out of like I think like black ABS sheets, just so we have something to represent a hopper, and so we can at least hopefully eventually get to a point to where we can have an intake, have a spindexer, have a shooter, and so we can even if it's just a couple balls, intake some, spindex, and shoot them. So the hopper is just something I think I'm just gonna really have to look at closely. We made a temporary thing, little corner piece at Lamar the other day. This can just get there's a tube plug at the bottom, so you can just bolt it straight into the belly pan, and then it'll work as a temporary cover up for now. I think eventually we want a very well thought out slope and very specific and really, yeah, just a really clean kind of slope. But again, that's right now it's a minor ish detail. And yeah, I think the biggest thing that I've personally been spending the most time on is working on the shooter. I realized last night, with this stuff that we have, copying the WCP shooter may not be the most amazing idea because of like they have different motors, and then the thing that I only realized like a day or two ago was the fact that they had 4-inch wheels, which I didn't know about. I thought they were using just standard 3-inch Colsons, but they're using 4-inch wheels. And I think it's a big thing because the bigger wheel lets them get more surface speed, and yeah, it just worked well with their compression. But we don't really have 4-inch wheels, and we have a lot of 3-inch wheels that I think we can make really good use of. So I think from now I might start. I saw Rev posted a YouTube short that showed them being able to shoot like a stream full of fuel and get every single one into the hopper really easily and really consistently. I think they use like a vortex and some 3-inch wheels. So I'm gonna look closer to that idea just because I think it's much more in line with the resources that we have and the stuff that we're gonna pull. They have much less compression compared to WCP, so I think it's gonna work a lot better. This is my current iteration right now. We discussed finding that balance between a tall versus a shorter shooter, and we haven't really reached a final decision. But a big thing that we pointed out is if we wanted to shoot over a climber, which we plan to do, we have to shoot over our whole hopper. So our shooter is going to naturally have to be relatively tall just because it has to shoot over our whole robot's height of 30 inches, basically. So what I have right now is I kind of just laid out the sketch and tried to make sense of everything that there is. Yeah, so all this is just we have a ball here, and the whole idea is we make this sort of kind of like what we did with our spindexer, where we have polycarb that's zip tied to churros. I was thinking as the backing of the ball path, we can do something like that because I've seen other teams also do it. Use that sort of backing to create this slope and create that really smooth ball path that the balls can go on. And I tried my best to make sure that there wasn't any dead spots. These compression numbers specifically, I tried to focus more on rev stuff. I think depending on how we want to do it, I think on the indexer itself, a lower compression may work better just so we can move the ball faster. The shooter compression, I'm going to try to keep that as close to rev as possible. That's a non-negotiable in my opinion, just because they proved that their shooter works really well. I think they have like the 3-inch rev grip wheels, so we have plenty of those from Crescendo, and we have a bunch of 3-inch Colsons. that have pretty similar properties. Yeah, this is what I've been working on. I think the biggest challenge is going to be getting a hood working. My plan with the hood is have it rest in basically have it rest on the top of the shooter plate itself. And then I'll need to pick between kind of an actuation point that comes from a pull it from this bearing hole and be a dead axle kind of, and then what I'll also a lot of common hood designs I've seen is like what Levi was trying to do with the 3D printed hood with gear teeth on the back of it and have a rack and pinion system to actuate. I think both are fine. It's just a matter of packaging and just generally what we want to do. So that'll come hopefully eventually. And yeah, we made a couple of small minor tweaks to the drivetrain, like adding these radiuses here in the corner. Just because Carl pointed out that having a sharp corner, even though it's filleted, can be a stress point. So we decided this would be a better option. The belly pan is probably going to be 1/4 inch polycarb, just because we thought having a heavy belly pan in this year's so having a belly pan would just slow you down without providing the sort of as much advantage with having a lower CG. We also decided that having a clear belly pan is going to be really important just for inspection, general reaching electronics and stuff like that. A clear belly pan is just going to make that process go a lot faster. So yeah. The intake, I've yet to really make the changes that we discussed with like the actuation. What I really want to do is do a max spline axle that goes all the way through. I have a max spline that goes all the way through because of the billet sprocket. It works. It already has a max spline bore in it, and I think max spline is a pretty good application here. It'd be a dead axle that we did it on Tombstone, and although that robot didn't see much actual actuation, the actual dead axle itself was actually really smooth, and we were pretty happy with that. So I'm gonna stick to that, or attempt to for this design. And with the climber, I think I know we had ideas between like a single climber and stuff, but I think if we want to play it quote unquote safe, I think the double climber is the way to go. Devanch has been working on this battery solution. We see obvious issues like this really thin part. So it's something that we're working towards. Is we're gonna keep it similar to how we did it in Crescendo, just because I think it's the simplest way to do it. And yeah, that's about all the CAD updates I have so far. Still lots of details to put in.
I will say that a 1/4 inch belly pan seems a little thick to me, but that's just my intuition working here. So, but for now, I think what we have is testable. To me, I think we really need to just focus on the most testable things to be ready by March 1st. So if someone says, "Oh, we need to cut a new belly pan," I'll say, lower priority. Let's make sure the intake's working. Let's make sure we can get the Spindexer on the robot, and we can cut some shooter plates. We got to get all the intake to Spindexer to shooter working, and see where our major problems are, so we can get those systems all working together.
Yeah.
And in worst case, if we have parts that we replace, I think they can go to Westside, and maybe Westside could cut some new rails and start making a clone of this drivetrain dimension. So,
yeah.
I like the double lift. So Lux and I put together the climber in the box. So we have one of them built, and it's pretty neat. That there is some tricks, it's a spring-loaded mechanism. So you really have to have the whole winch tied in to your motor, or else it just shoots right up out of the spring, if that makes
Yeah.
sense. So by doing a double, we're using twice the spring, which will, I guess, technically make it go faster. I don't know how much that will. I guess there's a little bit of pulling stuff happening, but I think we can tie them together through one shaft and run one
Yeah.
motor, and it should
Yeah.
probably work. So
Greg also had a good point to where the way that we have this set up, we have to kind of treat this kind of how we treated our elevator last year, especially with the rope, like making sure that if we want them both to be perfectly level, we need to make sure that that rope is equally tensioned and wrapped. The wrapping has to be mirrored across the both sides so that we have it's the exact same principle as we had last year. If we have the mirrored sides, they would have a consistent feeding and pulling of rope to make sure that both sides are always level. So something to think about.
yeah, I mean, there is reliability issues that we might decide we want to package a motor for each one, and then maybe make, if one of them's running. The problem is I don't know what's going to happen if you have an issue with one and they're tied together, how that works, because we've seen a lot of teams have independent climbing mechanisms, and sometimes they only hook on with one, and it still kind of works. But yeah, there's a lot of question marks. I think we just got to start building and come up with something that we can test out on March 1st. That's my goal. So I would like to change the CAD to add hooks, if that makes sense. So if we wanted to hang on the bar with this, is there a way that we can put hooks on the top to hang on the bar instead of do a side climb?
There's probably definitely ways to do it. I just haven't looked into doing that sort of center climb that much. Just by like judging off of our drivetrain dimensions, doing a center climb is just may be a bit tough. So
you may be able to use one upright, just a straddle type with the upright in the middle. The problem if you do center climb is, the other side's just going to hang down. So you have to literally get up about 8 inches to get, because it's not at all over the CG. But if you have an upright and you're going up against upright, it'll resist your force, so it won't rotate down. Or you can have a hook.
Carl also mentioned the nice thing about having this sort of design is obviously we don't know our CG of our robot yet, but it probably won't be dead center. So we can design whatever sort of plate we decide to design to connect these two plates. We can adjust the point at which we hang from to make sure our robot's balanced as we climb. I thought that was pretty neat. So
yeah, the other thing you could do also is if you have a cutout in your bumper, then you have the bumper literally holding you in place, so you can't rotate side to side. So I mean that's a pretty easy. You can be off by 8 inches and still you won't be able to rip your bumper off.
Yeah, that's an interesting bumper cutout. That might be something we want to throw up in CAD and get an idea of how we're going to do that. So that way, but we might just say side climb's the only side climb that we're going to do. We're not going to do the and that's fine. I think we got to just look at it. March 1st. What do we want this robot to do? Keep it simple, and just try to get our basic priorities done. And then if we want to upgrade, we can think about upgrades. So.
We could also start thinking about bumpers. We do have like bumper like wood dimension. You saw Enoch posted the wood pieces that we would need. It's in terms of style, it is basically a cut copy of last year's design because we were pretty happy with it. I think we added a little bit more tolerance here, or a bit more of a gap, just because this year we have those plates. We're gonna have a lot of plates that are bolted to our drivetrain, and so we thought we would just need more tolerance for those gaps. But if we want to start doing like at least getting the wood together and getting pool noodles on it, so we're ready for March 1st to get inspected and whatnot, that might also be a good idea to do.
So if we have a cutout, then our bumper latching is going to be a little different, right?
Yeah, because I think the style that we did last year, it really works best if you have a one piece full all around bumper, just due to the way that it latches on. So if we did have a bumper cutout right here, that may change things, whether that be, yeah, it would just make it a bit more complicated on this side, but it's definitely an option if we decide to do a bumper cutout.
So it would be a split bumper.
Kind of, yeah.
Or
It would either be, yeah.
Or two latches also. I mean, it could be literally just put two latches instead of one in the middle. It'll be two at both ends.
But
Yeah.
keep single bumper is what you're thinking.
Single buffer with just a 5-inch cutout or whatever, and then just go ahead and anchor it at both sides so it can't rip the bumper off when it's climbing.
Yeah.
Okay. Sounds reasonable.
Be able to like run a hard piece all the way through and then just like leave off the foam on one part, maybe. I'm not sure if that's legal. Does that make sense?
I
You have to
think
look
it
at
has to be open, but it's okay.
Yeah.